Welcome to the 13th episode of the Building Interactive website series, where we'll go over how to use numbers more effectively through arithmetic and JavaScript's various built-in math-related functions. So firstly, let's go over the basic arithmetic operators. So we can start by defining some variables for some starting numbers like x and y. And for example, we can set x to 10 and y to 5. And so the way we can add these numbers together is by using the plus operator in between the variable names. This adds the two numbers together, and x is 10, y is 5, so x plus y should result in 15. And we can check this by making use of this number display paragraph that we have here and changing its text content. So you can say num display dot text content equals x plus y, and you can see it returns 15, the correct result. To subtract one number from another, we can replace the plus with a minus. So that means it's subtracting y from x now. So it's subtracting 5 from 10, meaning the end result should be 5. And negative numbers can also be returned from these arithmetic operations. So if we were to do y minus x, then that would be 5 minus 10, which should equal negative 5. And as you can see, that's what returns here. That's what appears here. And so if we want to multiply x and y together, we do x times y, making use of the asterisk symbol. Since 10 multiplied by 5 is 50, 50 is what appears when we run the code. And so if we want to do division instead, we use a slash. And so x divided by y in this case is 10 divided by 5, which is 2. If we want to get the value of x to the power of y, there are two ways of doing it. One is by using two asterisks like this, which basically means to the power of, and x to the power of y is equal to 10 to the power of 5, which should mean, since 10 has 1 0 after it, then x to the power of 5 should have 1 followed by 5 zeros. And that's exactly what appears here. The second way of doing it is using a built-in function called math.pow. So the way we use it is firstly by typing math with m capitalized and the rest lowercase, and then dot to access the methods inside of it, and then POW to use the power function. This math.pow method takes two parameters, the first one being the base and the second one being the exponent. So if we wanted to do 10 to the power of 5 again, then the base is equal to 10 and the exponent is equal to 5. Or we can use x and y here. And since this method works exactly the same as the double asterisks, it should appear as the same result, and that's exactly what appears here. Additionally, we can just use numbers with the arithmetic operations here. So in really long and complicated expressions similar to this one, the order of operations is followed. So it handles, the JavaScript compiler handles exponentiation first, which is taking something to the power of something. And then it looks at multiplication and division from left to right. So this multiplication of 6 times 2 occurs next after the 7 to the power of 5. And then it handles addition and subtraction from left to right. So after these two are done, it adds 5 to 6 times 2, and then it subtracts 7 to the power of 5 from the whole thing. Sometimes this isn't the behavior that you want, though, and you'd rather have some other order that the expression is evaluated in. So what you can do is make use of parentheses around a specific expression to make that expression evaluate first. So previously, 6 times 2 would be evaluated first, but if we wanted 5 plus 6 to be evaluated and then multiplied by 2, then we can put parentheses around it. And now, as you can see, it returns a different result. Additionally, you can even nest parentheses inside of each other. So as you can see, this entire expression that comes before the exponentiation is evaluated first. And in this expression, 5 plus 6 is evaluated before everything else, which gives us a wildly different result in this case. Next, let's go over some more properties and methods of this math object. The first one we'll go over is math.pi, with pi all in capital letters. And as you can see, this returns the value of pi rounded to 15 decimal places, which is the best way that JavaScript can represent it. And this is useful when you want to calculate the circumference or area of a circle, for example. So if we wanted to calculate the area inside a unit circle, which has a radius of 1, then we can square the radius of 1 and multiply it by pi. As you can see, this is exactly the same as pi because 1 squared is just 1, but this makes it really convenient for other sizes of circles. Another property of the math object is math.e, which returns Euler's number rounded to 15 decimal places. This number is commonly used in areas like compound interest and calculus, which we won't get into here, but for now, it's good for us to know about this number and how we can access it. Next, we'll be going over methods of the JavaScript math object, which require a method name and then parentheses to call the method like a function, and then various parameters. Some methods don't have any parameters, while others have varying amounts of them. The first method we'll go over, which doesn't require any parameters, is math.random. When we run the code, you can see it generates random numbers between 0 and 1, and they're all randomly generated decimal numbers. This math.random can return 0, but it cannot return 1, which means it returns random numbers between 0 inclusively and 1 exclusively. The next method we'll go over is math.floor. This math.floor method takes in one single parameter, and what it does is it rounds the number down to the nearest integer. So, for example, if we were to type in 5.7, it would round down to 5. Or 61.8 would round down to 61. So for positive numbers, it basically just takes out the decimal part. But for negative numbers, it actually gets rid of the decimal part and subtracts 1 from it, because that's how you round a number down. So in this case, this would return negative 62, because that's the number you get when you round negative 61.2 down to the nearest integer. Math.floor and math.random can actually be combined to generate random integers from a specific number to another number, making use of this formula, where max represents the maximum value that can be generated from this random number generator, and the two mins representing the minimum value that can be generated. So if we were to run this code, you can see numbers from 1 to 10 randomly get generated. Another method is math.ceil, which takes the ceiling of a number, which means rounding it up to the nearest integer. So for example, if we were to do 4.1 in this case, it would round up to 5. And then for negative numbers such as 99.6, when rounded up to the nearest integer, this equals negative 99, which is what is returned here. Another method called math.round behaves either like math.floor or math.ceil, depending on the decimal part of the number. So it rounds a number to the nearest integer. So, for example, 1.1 is between 1 and 2, but when used with math.round, it'll return 1, because that's what it's closer to. And then if we do 1.8, 1.8 is closer to 2 than 1, so it'll return 2. However, if we do 1.5, even though 1.5 is exactly between 1 and 2, it'll round up to 2, because that's a standard convention for rounding numbers directly in between two integers. Another method is math.min, which can take any number of arguments and returns the minimum value of those arguments. So, for example, if we were to do 5, 6, and 7, all separated by commas, then the minimum of those values is 5, because it has the smallest value out of all of them. math.max behaves pretty similarly, but it finds the maximum of these values instead of the minimum. So in this case, 7 is greater than both 6 and 5, so it returns 7. And both math.min and math.max accept any number of parameters. So we can add more and it'll still find the greatest or least of all these numbers. Math.max and math.min can actually be combined to restrict numbers to a certain range. So as you can see, firstly, this inner math.min is what is evaluated first. So if number is greater than the upper bound, then this will return the upper bound, otherwise just the number. And then math.max will ensure that this number returned by math.min doesn't get too low, and that it stays within the lower bound as well. So as you can see, 5 is actually in between 2 and 10, so it'll stay as 5, but if we were to do 1, then it changes to 2, because that's the minimum value that this number can take. And this works for any number less than 2. And if we were to do a number higher than 10, it'll be restricted to 10. And this works for any number greater than the upper bound. Math.sqrt returns the square root of a number. So for example, if we were to do 64, 64 is 8 times 8, so it returns 8. Now, 64 is also negative 8 times negative 8, but it returns 8 because math.sqrt, the square root function, always returns a positive solution. This square root method also works for non-perfect squares. So for example, if we do the square root of 63, then we get an irrational number. And we can test it using other non-perfect squares as well. The last two methods that we'll be going over today are math.abs, which returns the absolute value of a number, which is its distance from 0 on the number line. So for positive numbers, it just returns that same number, but for negative numbers, it converts it to a positive number. So for example, if we do negative 450, negative 450 is 450 units away from 0 on the number line, and so that's what it returns. The final method we'll be going over today is math.trunc. What this method does is it takes a number that's usually not an integer and makes it an integer by removing its decimal part. So if we strip 0.1 away from 1.1, then it'll just be 1, which is what math.trunc returns. It works similarly for negative numbers, so if we do a negative 2.33, for example, then it gets rid of 0.33, making it just negative 2. Thank you very much for watching episode 13 of this series. Make sure to look out for episode 14. Hope you enjoyed.